Hello everyone, myself Ravi. Welcome to this video of S.MONK. In this video, we are going to discuss the first topic of the subject CM1, which is called actual mathematics, and the topic name is theory of interest rates. So in this topic, we have to understand what are the interest rates and how to mathematically calculate interest rates for short or long period of investments. To understand interest rate, let us first understand a basic concept of time value of money. So our topic under the chapter is time value of money. Now, before you start watching this video in detail, let me discuss a few rules with you that you need to follow while watching these videos. So there are several videos made for each and every topic with adequate number of questions to practice. So when you sit to watch these videos, make sure that you sit with a pen and a paper and keep a note of whatever I am writing on the board for your own practice later on, because you may not remember everything that has been spoken unless you have written it. So make sure that you write things as and when they're spoken. If I am speaking something which is important but I have not written on the board, you can always note it down. So identify the important points that is being spoken, whatever things that comes new to you, and make note of everything. Whenever I solve sum, initially what you have to do is you have to look at the board, look at the video and see how the sum is being solved. But later on, once you get used to solving the sum and if I'm still practicing the same kind of sum, you can always pause the video, solve it yourself first, and then cross-check with the video how it is being solved in the video. If you see that the methodology or the answer is different, you can always judge which one is better. The answer should be definitely same, but if the methodology is different, then you can always judge which methodology is better, and accordingly you can make sure that you can decide which method is supposed to be followed. Your method is more time consuming or my method is more time consuming. The one which is time consuming need not to be followed. You have to go for the most efficient methods to solve this sum, because there is a limited time in the exam to attempt the paper. So make sure you be active, very active. Whenever you want to write something and if you feel that there is no adequate time in the video to make note of things, you can always pause, make a note of whatever you're supposed to write, then restart it. Rewind and watch the videos as many times as you want until you understand the concept. Only once one of the videos is completely clear, then only move on to the next video. Because the subject is such that every chapter has got some connection directly or indirectly to the previous chapter. So if you've not understood one topic, moving to the next topic directly will be a problem, because you may not then be able to relate to some of the concepts discussed in the next video if the previous video concepts are not clear. So make sure that you clear everything in your mind, in your brain. Be sure about every concept that is discussed in one video. Make thorough notes, solve adequate questions related to those videos or the topics discussed in the videos, and then we move on to the next video which is being provided to you. And if anything is not clear, very clear, you can always get in touch with us. So I am always available on WhatsApp and Gmail account, or you can always give me a call. We can discuss whatever topics are not clear. If sometimes it happens that some topic is unclear to many of the students and I get the same feedback, I can make a different video, a new video for the same topic and give it to you. So that is always a possibility that some of the concepts may not be very clear at the first view. So I have different methods for understanding of teaching the same thing. So if something is not very clear to you, just give me a buzz. I'll always make sure that a new video is supplied with a different explanation which may help you understand the video or the concept more clearly. So make sure be active and be in touch whenever you're watching this videos till the end of the course or till the exams definitely. So now, keeping these rules in your mind, we can start with the first topic. So the chapter name is Theory of Interest Rate and the topic is Time Value of Money. The first topic in the chapter. So in this video or in this chapter, we are going to understand what are the interest rates, how are these interest rates calculated, and how are these interest rates, what are the mathematics involved to calculate the interest rates, and what are the types of interest rate there for sure. So first, let us understand what is time value of money. So I'm sure we all agree with the fact that the value of money keeps on changing with time. When I say value of money keeps on changing with time, it means that the purchasing power of the money keeps on changing with time. So prices of goods and services that we generally consume usually tends to rise with time in all the major developed or developing economies. Somewhere, like in Japan, it has been seen that the prices have been reducing consistently. They have faced deflation, which is called negative inflation. Otherwise, when the prices are rising, we call it inflation, that the prices of goods and services are increased. And some sort of inflation is always good for the economy. You should always have inflation. which is an indication that demand is still more than supply, so there is a more scope of production in the economy. This is a rise in prices of goods and services. So usually, you must, if you have seen newspapers, if you read newspapers, you must be knowing that the inflation in India is coming down day by day. So usually 3-4%, 2% inflation in the economy is considered as very healthy. We have right now, I think, 5 to 6% inflation in the past few quarters, which was 5 years back, 7 years back, it was more than 10%. So prices have been increasing at the decreasing rate, which is healthy and which indicates that the supply is growing at the same level. So which is a good indication. So inflation should be there always, which is a good thing. The prices should keep on rising. But again, keeping in mind that the standard of living or the income level of the people should also rise at the same time. So that topic is apart, but right now we just need to understand what is inflation first of all to understand dynamic money. So here is a definition for you that inflation is the rise in prices of goods and services. As simple as that. Now let us understand how interest rate is linked to inflation. So let us understand this with a very simple example. So today, let's say it's 1st November 2018. I was having some free time, so I went to a shop to buy a t-shirt, let's say. So when I shortlisted a t-shirt, that t-shirt was worth rupees 500. I was just about to make the purchase and I got a call from a friend. And my friend was asking for some money because he was under distress and he required some money urgently for next 1 month. So he was supposed to return me money back after a month, and since he was my friend, I had a compulsion to pay him. So I paid him that 500 rupees and I sacrificed the t-shirt for the time being. So let's say I paid to a friend, I cancelled plan and I paid to a friend rupees 500. On 1st December 2018, the rupees 500 is returned. Friend returns rupees 500 to me. So now I gave 500 to him and he gave back 500 to him. I did not charge him anything extra because he is my friend. So I cannot charge anything extra. So I felt that I made no profit or no loss on this transaction. My friend felt that I'm so generous that I made no profit out of this transaction. I basically gave a loan of 500 rupees to him and I did not made any profit out of it. So we both were happy and settled that we made no profit, no losses. Now on 1st December 2018, when I go to buy the same t-shirt again now, the t-shirt, to my surprise, is now costing me 550 rupees. So now when I gave money to a friend, I was worth, the money that I owed was worth one t-shirt. Now when that money comes back to me after a month, that money is not worth one t-shirt. Now the t-shirt has remained same, the t-shirt has not changed. The size, the color, the brand, everything is same. But the value of my money has reduced over the time period of 1 month. So usually it doesn't happen practically that it changes so drastically in a month, but let us just assume for an example that it changes by 10%. So here the inflation in this month was 10%. So value of my money has now reduced by 10%. So now to buy a t-shirt, the same t-shirt, I have to spend 50 rupees from my own pocket. So now initially I felt that I made no profit, no loss, but now I realized that I actually made a loss of 50 rupees by giving that money to a friend and just taking the 500 rupees from him without any extra compensation. So that's where the loss comes into picture. My loss was actually 10% in real terms. When I say in real terms, it means considering inflation. And in money terms, my loss was actually 0%. I gave 500, I took 500, there was no loss. But when you look at the dynamic money, you realize that you made a loss of 10%. So here is where the interest rates get linked to the inflation. So to make sure that I actually do not make a loss, even if I don't want to make a profit, just to make sure that I do not want to make a loss, I should charge at least 50 rupees to my friend before lending money to him. Now if he is wise enough, he'll understand that the value of money has changed by the time he returned it to me. So he should give me 550 rupees back. So basically I gave him money worth one t-shirt, he gave me back money worth one t-shirt. That is how it should be. Then it is no profit, no loss, otherwise it is loss making for me. So this extra money that we seek, the 50 rupees that I should have seeked from him on this transaction is called as interest rate. So interest rate is nothing but the compensation that the borrower pays to the lender for using his money. compensation paid by borrower to lender for use of his money. As simple as that. So interest rate according to this should always be equal to inflation. And there is one more factor which should take into account is risk. So how much interest rate should be charged is very subjective. It depends on what kind of person I am giving my money to. So if you are investing sometimes with the, let's say, Government of India. Now Government of India is a huge entity, it has got a lot of money. So there is rarely any chances or very less probability that the Government of India will default and not pay your money back. So the risk part is almost zero. It is not exactly zero, but it is very close to zero. The second kind of entity can be a corporate sector, which is not a government entity, maybe something like Tata's or Reliance, which are huge in size. So again, there is a very rare chance that they do not pay back the default on the payments. But again, the probability is again not zero, but little bit more than the government, that the probability of the default may happen. So there is a risk, but not huge. So you'll seek a smaller risk compensation. Now let's say you give money to some entrepreneurs or a company, let's say for example, my company, S.MONK. So suppose I need capital and I ask you to put some money to me. Now there is an option with you to invest 100 rupees in Tata and there is an option with you to invest 100 rupees in my company. So of course, you will feel that my company is more risky. So you'll invest in my company only if I compensate you with a higher rate of interest. I have to make the investment in S.MONK look more attractive to you, more lucrative to you. Only when you say it is more attractive, you will be ready to take the risk of investing your money in S.MONK where there is a more chance that the money may not come back. So in smaller entities, there is always a higher probability of bankruptcy or higher probability of default. So the risk is very subjective and it depends very much on whom you give your money to. So that's what the concept of interest rate is and how it is linked to the inflation rates. So inflation rates, interest rates go hand in hand. Interest is always greater than inflation. Otherwise, you are basically losing money. Even if you're charging interest, or if it is less than inflation, you are still losing money in real terms. So that is what the time value of money is, and that is how the concept of interest and inflation is linked with each other. Now, if this at least the basic understanding of interest rate is clear, now we can move on to the understanding how mathematical interest rate is taken into account and how the sums of cash flows including interest rates are solved. So let us move on to the next topic, which is called interest rates.
Okay, so now let us understand the mathematics of the interest rates. So I am sure you must have studied this sometimes before. Definitely, what are the types of interest rates? There are two basic types of interest rate. One is the simple interest, and another one is compound interest. Very commonly used and very basic and very simple to understand concepts. So simple interest, as you all know, is an investment where the interest will not earn further interest. So when you put some money in the bank account, the initial principal amount will earn interest every year, but the interest accumulated in the previous years will not accumulate further interest. We'll see this with an example right now. And compound interest is somewhere where interest itself earns interest. So we can write very basic definitions. Simple interest is where interest does not earn further interest, and compound interest is interest itself earns interest. Let's see how this works with an example. So if I put my money in a bank account, when I write, this is what I'm trying to make as a timeline. So let us understand how this actually works. When I say time 0, it means today, point where you're standing. When I say time 1, it means 1 year from today. Time 2 is 1 year from 2 years from today. Time 3 is 3 years from today. So this from time 1 to time 2 is I can say point 1 is end of the first year or start of the second year. End of the first year or start of the second year is point 1. Point 2 can be referred to as end of the second year or start of the third year. So whenever I say start of the third year, you have to refer to point 2. When I say end of the third year, you have to refer to point 3. When I say start of the first year, it is time 0. When I say end of the first year, it is time 1. Start of the second year, time 1. End of the second year, time 2. So that is how it works. Now, after having understood the timeline, now let us see an example. So let's say if I invest 100 rupees over here, that's my the initial amount that we invest is called principal amount, P. Let's call it P. And let's say the bank is paying the simple interest 10% per annum. The time unit is very important. So for what time that interest, that percentage is mentioned is very important to understand. So if I invest 100 rupees right now, the bank is going to increase my amount in the bank account by 10% every year. So by time 1, you will have 110 rupees in account. This 100 rupees will increase by 10 rupees. Now in the second year, I actually have 110 rupees in the bank account, but still the bank is going to pay me interest on that 100 rupees only. So how this becomes practically problematic, because the investor has got his new 100 rupees still in the bank account, but the bank is paying no interest. So there is no incentive for the investor to not withdraw this money from the bank account. So what investors will do is they will withdraw this 110 rupees. So that's how practically simple interest is not feasible. But right now, just to understand, the bank will not pay any kind of interest on this further 10 rupees. They will only pay interest on this 100 rupees. So again, 10% of 100 rupees is still 10 rupees. So you will have 120 rupees in your account. At the end of 30 days, similarly, you have 130 rupees in the bank account. So amount of interest that is being credited every year is exactly same, and that is 13% of the initial principal, and no further interest on no interest that is already credited will earn further interest. That is how it works. Now if I say that I am earning simple interest, compound interest 10%, as the definition says, interest itself earns interest. So right now I have only 100 rupees in the account, that is what I have invested at time 0. That will increase by 10% here. There is no difference in the amount by the end of year 1. By the time I go to year 2, in the second year, at the start of second year, that means at time 1, I have 110 rupees in the bank account. Now, the bank will pay me interest on this 110 rupees, not on the 100 rupees. So, 10% of 110 is 11 rupees. So, by the end of year 2, I will have 121 rupees in my account. 110 increased by 10%. Now, in the third year, the bank will pay me interest on 121 instead of 100 or 110. So, 10% of 121 is 12.1 rupees. So, if you add 12.1 rupees to this 121, it becomes 133.1 rupees. So, as you can see very clearly, the amount in the bank account which pays compound interest is definitely going to be higher than the simple interest account, because your interest is also earning further interest, right, at the same rate 10%. That is how compound interest, simple interest works. In practice, in real life, in all the organized financial sectors, you will never see any kind of company or any kind of organization using simple interest. Usually it is by default compound interest only. Whenever you face any kind of exam question, if the question simply says interest rate 13%, it by default means compound interest 13%. When the question says simple interest 13%, that means it is simple interest. So until and unless the question uses the word simple, always consider it to be compound. If the question specifies it is simple, then it is simple, otherwise it is always compound by default. Keep that in mind very clearly. So since it was for 3 years, we could calculate very easily without even the use of calculators, without any formula. Now what if I say the investment is, let's say, for 45 years, 100 years, 70 years, 80 years, then you cannot sit and calculate manually. So we need to devise a formula which can help us do this calculation. So let us try to derive the formula, which is very simple. So first is the case of simple interest, second is the case of compound interest. At time 0, I have P rupees in my account in both the cases. I have P rupees in my account. Now at time 1, that means by the end of first year, this P rupee will earn some percentage of interest. Now my I is the rate of interest, which I assume here to be 10%. So if I think of that formula, P is 100, the initial amount that I had invested, 100 rupees. The I is 10%, 0.1. So 100 into 0.1 is 10 rupees. So 100 plus 100 into 0.1, 10%. That makes it 110 rupees. The same formula should be used here also because the amount was exactly same. So I can write this as P into 1 plus I. This also I can write as P into 1 plus I. That is how you'll get the value at time 1. P is the principal, I is the interest amount. At time 2, in simple interest case, you will have P plus PI, the original amount, plus the same amount being added again, because the amount of interest that you are earning every year is remaining definitely same. This becomes P plus 2 into PI. If you take P common outside, this becomes 1 plus Y. Clear? And in case of compound interest, there is a twist. You had P into 1 plus I in the account already. Here I use P plus PI to make it simple. Here I am using P into 1 plus I because that will make it look more simple. So P into 1 plus I was the amount you already have, and P into 1 plus I into I. Instead of P into I, here the interest amount that is being credited will be certain percentage of the amount that you have at time 1. So P into 1 plus I is the amount that you have at time 1, and certain percentage of this amount is added to the amount that you have at time 1. That is how the formula works. Now we take P 1 plus I common outside on these two values. The first value is 1, the second value is I, which makes it P into 1 plus I squared. That's how the formula comes from the second. Similarly for third, if I think, here it becomes P plus 3 into PI, because the same amount is again credited, so this becomes P 1 plus 3I. And in case of compound interest, I have P 1 plus I square plus P into 1 plus I square into I. Certain percentage of the amount that you have at time 2. This amount plus certain percentage of this amount is then added. Now again you take P 1 plus I square common outside. You have 1 plus I left, which makes it P 1 plus I cube. So now you can see the pattern. At time when it is 1 plus I, at time 2 it is 1 plus 2, at time 3 it is 1 plus 3I. So I can say that in general the formula should be for any time n, P 1 plus Ni should be the amount that you are holding in your bank account. And here the formula should become P 1 plus I raised to n, because at time 1 it was 1, at time 2 it is 2, at time 3 it is 3. So for in general any time n, it should be n. So if you want amount at time 10, you will make it P 1 plus I raised to 10. If you want amount at time 7, P 1 plus I raised to 7. That is how it works in general. So very easy formulas. I'm sure you must have seen these formulas in the schools, but at those point of time you always just see the formula in the textbooks and you just copy it and you use it. Now it is very important to see from scratch how a formula is derived. So for each and every formula, if you know the basics how the formula is being derived from scratch, it becomes very easy to manipulate or to play with the formula for whatever kind of questions that you face in the examination. So let's make sure that we do this every time when any kind of formula is being discussed in the lecture, or which is supposed to be applied in any kind of situation, in any kind of topic. So make a note of these things. These are the this basically tells you the amount that will be holding in your account by the end of n years, using simple interest and using compound interest. So now we know what is the accumulated value using both the formulas. I can see accumulated value. Let me write the word completely. When I use the word accumulated value, it means the amount that you hold in your bank account after a certain number of years of investment, which includes the initial principal invested along with the interest rate that is being credited. So when in the previous example, when I invested 100 rupees and I had 130 rupees at time 3 in case of simple interest and 133.1 in case of compound interest. That 130 or 133.1, the respective amounts were called accumulated values, which means that the principal amount along with interest, how much money you are holding in the bank account after a certain number of years of investment. So accumulated value for simple interest is P 1 plus Ni, and for compound interest it is P 1 plus I raised to n. That is, these are the formulas we just derived. So P being the initial principal amount, just make a note of this things. P is the initial amount, n is the number of years of investment, and I is the rate of interest that you are earning every year. Here I am assuming time unit is per annum, but that can be changed very conveniently. Let's say if the question says the interest rate is 1% per month, the only changes that you have to make in the formula is 1% you have to use for I, and n in that case should be the number of months instead of number of years. When you're using I as the annual interest rate, use n as the number of years. When you're using I as the interest rate for 6 months, write n as the number of 6 months during the term of investment. So let's say if I'm investing for 2 years, and if the interest rate given is per annum, you should use n as 2 in the formula. If the interest rate given is per month, use n as 24 in the formula, 24 months and 2 years time. If the interest rate is, let's say, per quarter, 1 quarter means 3 months of the year. So if interest rate is per quarter, so there are 8 quarters in 2 years. So your n should be 8. So just make sure the formulas, keep in mind the formulas are applicable for any kind of time unit. Just make sure there is a consistency in the time unit of interest rate and n. So based on what time unit or what interest rate per what time unit is given, you have to change the value of n accordingly. That is the only thing you have to make sure. Now this P was the initial amount, and this was the this is the number of times by which the initial amount is increasing. This factor is called as accumulation factor. Accumulation factor basically gives you the number of times the initial amount will increase. So if I say I'll invest 100 rupees and I'll get 250 rupees back, I say my accumulation factor is 2.5. So 2.5 times of the initial amount will be repaid to me when the investment matures. So accumulation factor for simple interest can be said to be 1 plus ni, and for compound interest it can be considered as 1 plus I raised to n. Accumulation factor is denoted as accumulation from 0 to n, or we can write any time from which the accumulation factor of the investment is starting and the time when the investment is going to end. We'll see this in more detail in the further lectures, but for the time being, since we're investing at time 0 and redeeming at time n, let us use the letters 0, n, or you can use just an. One the same. If it is starting from 0, you can just write an. If it is starting from some other time which is not 0, you have to mention the time over here. So in that case, you'll be able to use only this kind of a format of writing the accumulation factor. So accumulation factor of simple interest, accumulation factor of compound interest. So accumulation factor basically tells you how much times of the initial amount you will get your money back whenever the investment matures, or we use a word whenever the investment redeems. Redeems means whenever it expires or matures. One and the same. We'll be using the word redemption more often than the expiry of the investment time period or the maturity of investment product. So keep a note of these words when you're studying the subject now. So this is it for the simple interest and compound interest part. Let us look at a few questions now before we move on to the next topic. So now let us solve a few questions on this. So let's say a question, very simple question. Let's say I invest rupees 500 in an account paying interest rate as per follow. So we'll try different interest rates and we'll see what are the answers. Let us assume that the number of years of investment is, say, 7 years. Simple. I invest 500 rupees for 7 years, and the rate of interest by which I am getting money back is dependent on the interest rates that I am mentioning now. So let's say the bank is paying me simple interest 10% per annum. Okay. So its solution should be 500 1 plus ni. N is 7 into 0.1. Let us see what is the answer. 500. Just write the whole thing in the calculator as I have it on the board. You need to calculate things manually. Try to save as much time as you can by using the calculator. the answer comes out to be 850. So 10% being 50 rupees per annum. So for 7 years it is actually 350 rupees. So that could have been done manually also, but make a habit of using calculators to save as much time as you can. Let's say now simple interest is 5% per half year. 5% every half. The answer is going to be same in this case since it is simple interest. We'll see to it in some time that 10% per annum and 5% per half year may not be similar or same for compound interest. But for simple interest it is same. How it is not same for compound interest that we are going to see in the next example. So for the timings for simple interest, the answer is going to be same 500. Just the way of writing should change. Now since I have given you the interest rate every half year, you should write a formula in terms of half years. So in 7 years, there are actually 14 half years which will give you interest of 0.05 per annum. 5% is 0.05, that's how we write it. 10% is 0.1. This will give you answer as 850 again. Same. Let's say the interest rate is simple interest 10% per annum for first 5 years and 12% per annum thereafter. Two interest rates given, the interest rate is changing at time 5. So here what you need to do is 500 1 plus 5 into 0.1, that will accumulate the value from 0 to 5, and then 1 plus 2 into 0.12. Make sure that the accumulation factors are multiplied with each other, not added. So the concept here is whenever the interest rate changes, so now initially it was 500 rupees invested, which was earning 10% interest. So 500 rupees 10% per annum set 50 rupees every year. So in first 5 years your amount will already accumulate to 750 rupees. Now whenever the interest rate changes to 12%, the further interest rates will be paid on 750 rupees, not on the 500 rupees. So whenever the interest rate changes, it becomes like compounding. So your interest will also start earning interest when the interest rate change. So 500 turns to 750 rupees in first 5 years. Then 750 rupees will earn 12% and 12% in the next 2 years. That is how it works. So this is how we should write the formula. The accumulation factors can be multiplied to each other. That's why it is called as factors, because we doing this, that in mathematics we use the word term for anything that can be added or subtracted, and we use the word factor for something that can only be multiplied and divided. So when I say accumulation factor, you cannot add accumulation factor to anything. Accumulation factor can only be multiplied to something. Accumulation factor can only be divided by something. That is how it works. So here let's see what is the answer. So in my calculator the answer comes out to be 930. Now by any chance if you notice some errors in the videos, now being human I can also make sometimes some mistakes while writing the answers over here. So if you see any kind of mistakes in the answers, just please bring that word notice so that we can rectify it for other students. That will be helpful. So 930 is the answer for the time being, when it earns interest of 10% for first 5 years and 12% for next 2 years. That's correct. I just cross verified it. Let me say the fourth example. My amount earns compound interest at the rate 8% per annum for all 7 years. So my answer should be accumulated value should be 500 into 1 plus 0 raised to 7. 1 plus I raised to n. That's how the formula works that we just noticed or we just derived in the previous part. So 500 to 1.08 raised to 7 gives me the answer of 856.912134 rupees. While doing CM1, make sure that we do not round off your values. Maintain at least 6 decimal points in all the answers. If if the answer is final, if that is not going to be used anywhere else further, it's okay to keep it into 2 decimal points. But if you know that the answer is that amount that you have just figured out is going to be used somewhere in the further calculations, maintain 6 to 7, 8 decimal points to keep accuracies intact. So that is very important. Rounding off will lead to an errors in the answers, right? So the amounts are smaller, so errors may not matter. But when I say answers are in billions or millions, that time a smaller difference or the smaller rounding of error may create difference of thousands of rupees in the answers. So be sure about it. Let's look at another example where I say the compound interest is say 4% for half year. So your accumulated value in this case will become 500 into 1 plus 0.04. The interest rate is for a half year. So now my n in this case should be number of half years in those 7 year period. So in 7 year period, the number of half years are 14. So let me see how the answer changes. 1.04 is to 14 gives me the answer as 865.838238 rupees. So my answer changed. I have earned more rate of interest. 8% per annum and 4% every half year. Sounds similar, looks similar, but it is not actually same. So when you're earning 8% every half year, you got 8 rupees, and 4% every half year give you 865 rupees. How did that happen? So basically, when I say I've invested 500 rupees and I earn interest 4% for the first half year, so what is the 4% of 500 rupees? It's 20 rupees. So in the first year, at time 0 I had 500 rupees, at time 0.5 I already had 520 rupees. So for the second half year of the first year, will have interest earned on 520 rupees instead of 500 rupees. While when you think of this case, for the whole 1 year, you're getting 8% of 500 rupees. But in this case, the interest starts earning further interest very quickly, much earlier than what the initial case was. If I make it 2% every quarter, your amount will further increase, because the frequency of the interest that is being credited to you has been increasing consistently. So since the frequency is now increasing of the payments, the interest starts earning interest. The fund of compound interest, where the interest also earns interest. This interest earning further interest will start more sooner than the annual cases. So that's how it works. If I make it 16% every 2 years, the amount will be smaller than this, because only in 2 years the first interest payment gets credited. But here every 6 months it is getting credited. If I make interest rate being paid every month, the amount will further increase. So you increase the frequency of payments of the interest rate, your accumulated value goes on increasing. You decrease the frequency of payment of interest rate, your accumulated value keeps on decreasing, because interest itself, earning interest part reduces. So that's how it works, which is very interesting in practice. So the whole of the next few hours of videos is based on this kind of principles only. So we'll see this in very much more detail in this topic itself, this chapter itself. For the time being, let us limit to this example. We'll come back to this. Keep a note of it. Don't forget it at any point of time, at any cost. Now, the last example for this question, I say the interest rate is 8% per annum for time between 0 to 5 and 10% per annum for time greater than 5. So in this case, your accumulated value should become 500 into 1.08 1 I raised to 5 into 1.1 raised to 2. 1 plus I raised to n into 1 plus I raised to n. 2 times the interest rates have changed, so I'll use the different interest rate to get the answers. Now put the whole thing in the calculator at once. 500 into 1.08 raised to 5 into 1.1 raised to 2, and that gives me my answer of 888.9434865 rupees. So that is how you deal mathematically simply with the simple interest and compound interest concepts. These are very interesting and very easy concepts to remember. So make note of these questions, and now we are moving on to the next topic. And we have supplied some questions along with this videos to you. Make sure that you solve those questions if you want to immediately before moving on to the next topic, or you can move on to the next topic which is also similar and then solve the question, whatever way